Hi, this is Physics Unit 1, May 2017. So let's start. Number 1. Which of the following is a vector quantity? So option A says that distance. So distance is basically the path that we have covered when we are traveling. For example, if we are at point A and we go due east from point A to point B, and we go due south from point B to point C. So for example, we are traveling 20 kilometers from point A to B and 20 kilometers from point B to C. So the distance traveled is the path we are covering in our journey. So the distance traveled it will be 20 plus 20, which would be 40 kilometers. But there is another term which is displacement. So displacement is far different than distance, since displacement is the shortest distance between 2 points. So the shortest distance from A to C would be this distance, right? So this distance we have to calculate. This is right angle. So using the Pythagorean theorem, we can say that AC is 20 squared plus 20 squared. So we can clearly see that the distance and displacement are not the same. So a vector quantity. So a scalar, and so there are two type of quantities. One is a scalar quantity and one is a vector quantity. A scalar quantity has something that has only magnitude but no direction. For example, time. We can say 5 seconds or 10 seconds or 15 seconds or so. So scalar quantity is something that has only magnitude but no direction, and a vector quantity is the one that has both magnitude and direction. So distance is basically a scalar quantity because it has a magnitude of 20 plus 20 kilometer, but it does not say anything about the direction. So speed is basically distance by time. So since time is a scalar quantity and distance is also a scalar quantity, speed is a scalar quantity. So velocity is not distance, is displacement by time. So as I have said earlier, the displacement is the shortest distance between 2 points. So the displacement of A to C might be 45 degrees, right? So the displacement might be over 20 square plus 20 square due east, or 20 square plus 20 square root over 45 degrees due south or due west. So this 45 degrees is a type of direction, right? So displacement has both magnitude and direction. So displacement is a vector quantity, time is a scalar quantity. So since the right hand side has a vector quantity, velocity would be a vector quantity. So the answer is C. Part D is not correct, since work done is basically force into distance moved. So force is a vector quantity and distance moved is also a vector quantity, and we need to keep in mind that vector into vector is scalar. So in this way D is not correct, and the correct option to this answer is C. Number 2, which of the following is the unit for of upthrust? So upthrust is basically a type of force, right? So we just need to say that since upthrust is a type of force and force is always in Newton, so the correct answer would be D, since any type of force is in newtons. Number 3. When a force is applied across the ends of a sample of wire, the wire extends till it fractures. So at point W, the wire fractures. The force extension graph for the sample of wire is shown. Yes. So Z is basically the limit of proportionality. So the limit of proportionality is proved by, when we zoom in, we can see that this is a straight line, and after this there is a bend like this. So since there is a bend, it shows that after point Z, the force and extension are not proportional. So since they are not proportional and the graph is not straight anymore, Z is known as the limit of proportionality. So after Z, after the point of the limit of proportionality, the line is not a straight line anymore. And point Y is the elastic limit. So elastic limit is basically when the wire is extended to a point, to an extension, when the force applied is released, it will not return to its original length. So y is the elastic limit and x is the yield point. So when there is a force up to the point X, the spring will lose most of its properties. So X is basically the yield point. So a force is applied to an identical sample of the wire and then removed. So force is applied and it is then removed. If the sample of wire is returned to its original length, is the maximum force that can be applied. So return to its original length is basically we should not cross the elastic limit, and since the elastic limit here, as I have told a bit earlier, that the elastic limit is y, we should not exceed the force greater than y, since if we exert a force greater than y, then the wire will not return to its original length. So the answer to this question is C. Number 4. A small stone of mass m, so this is a stone and it has a mass m, is dropped into a pond and accelerates downwards. So for example, we have pond surface here and we dropped it into the surface of the pond and it sinks in, and after that, it is when it is in the water. So when the stone is in the water, the force, the free body force diagram is this. So the free body force diagram for the stone is shown. Yes. Which of the following equation is correct for the stone? So the thing is, the thing that we need to consider is if it is accelerating downwards or if it is moving at a constant speed. So if the stone is moving at a constant speed, then we will know that it has reached terminal velocity. So at terminal velocity, what happens in terminal velocity? At terminal velocity, the speed increase, the speed does not increase or does not decrease, the speed is constant. There is a constant speed because the constant speed is due to zero acceleration, right? Why zero acceleration? Since F equals to ma, we have F equals to ma. Since there is zero acceleration, there will be zero force. And when will there be zero force? Zero force means there is no resultant force. So the vector sum of all the forces in the object cancel out. So if it said that it accelerates instead of accelerates downwards, if it said that object is at terminal velocity or it is moving at a constant speed, so in that case the downward force, the sum of downward force would be equal to the sum of upward force. So mg would be equals to upthrust plus drag. So mg would be equals to upthrust plus drag. So mg minus upthrust minus drag would be equals to 0. Since it would be accelerating, it would not be accelerating, the acceleration would be 0 and there would be constant speed. Then the constant speed means there is no acceleration, so no force, so the resultant force would be 0. But since it is saying that it is accelerating downwards, so there is an acceleration. Since there is an acceleration, there would be a resultant force. So the resultant force is equals to ma, right? So mg minus u minus d would be equals to ma, since there is a resultant force. So this would not be the answer. This would be the answer in case it was moving at a constant speed. At terminal velocity, it would be moving downwards at terminal velocity. Then this would have been the answer, but this is not the answer since it is accelerating downwards. Since it is accelerating downwards, this means that when there is acceleration, there is a resultant force. So this is the answer. So the answer to this question is D. So question number 5. A student throws a ball vertically upwards and catches it after 4 seconds. So it throws the ball vertically upwards. So it throws the ball vertically upwards when it has 15 meter per second, right? So it has a 15 meter per second at the moment the ball is rising up, and since the ball will be rising up, it will be decelerating, right? Since it is moving against the gravity. So when the ball will be at the topmost point, at that point the velocity would be 0, right? Since for example here we have a ball and we throw the ball upwards, it will move up, and at this point the velocity of the ball would be 0 and it will start to accelerate again, so the velocity would be increasing. So it is moving upwards, so there is positive velocity moving upwards. At this point ball is here, and at this point again when the ball reaches the ground, it again becomes 15, but it's minus 15 now. Why minus 15? Because the direction is in the opposite direction to the initial direction, so the sign would also be different to that of the initial direction. So using the graph, what is the acceleration of the ball? So what is acceleration? Basically, acceleration is change in velocity by time. So change in velocity by time. What is the gradient of this graph? The gradient of this graph is velocity by time. So the gradient of this graph, since the gradient of this graph is velocity by time, so gradient would give acceleration. So the change in y by change in x, right? Change in y is v. Change in v, if we consider this triangle, then we would see that this triangle has in y. The change in y would be 15, right? It is going from 0 to 15. So 15 divided by 2 seconds, right? 15 by 2 is 7.5. So the gradient is 7.5, but what we have to know is the graph is moving downwards, so it has a negative gradient, so the sign of the graph would be negative 7.5. It would have been 7.5 if the graph looked like this, if the line went upwards. At that moment the gradient would have been positive, but in this case the gradient is negative, so the answer to this question is B. Question 6. Using the graph, what is the total distance traveled by the ball? So the total distance is basically the area under the graph. Since the area under the graph is basically velocity to time, right? So we know that speed equals to distance by time. So distance would be equals to speed into time. And the area under the graph would also give speed into time. This is speed or velocity and this is the time, right? So these two, we can prove that the displacement or distance traveled by the ball is represented by the area under the graph. So what is the area under the graph? So basically it travels a distance till it reaches the top point, and it travels the same distance to travel from the top point to the bottom. So basically the thing is, the total distance traveled is the distance traveled, the distance between the ground and the top point, multiplied by 2. So this is the distance from the ground to the top point, which is 15 into 2. So the area under the graph would be half into 15 into 2. So we will have half into 15 into 2, and this is the distance traveled from the ground to the topmost point. So the same distance will be traveling when the ball will move from the topmost point to the ground again. So from here to here the same distance will be traveled. So this into 2, so we will have 15 half into 2, and half into 2 is 1, so 1 into 15 is 15 into 2 is 30, so it will be 30 meter. So the answer to this question is C. Number 7. An object of weight W is on a slope at an angle theta to the horizontal as shown. The normal contact force is R. So as theta increases, R will. So the thing is, here what we need to consider is the component of these. So this would be W sine theta, and since here is a reaction and the force in line with reaction is something, so this would be theta. If this angle is theta and this is W, this component would be W cos theta. So we can clearly see that there is a relation between R and W cos theta, right? Since they're lying in the same line. So we can write that R equals to W cos theta. This is the equation, R equals to W cos theta. So 1 or 3 is the answer. So now what we have to know is, when the value of theta increases, what does the value of the overall R does? So the thing is, if we plot the graph for cos theta, we will have cos theta here and the value of theta here. So we have something like this, right? Since this is 0, this is 90 degrees, 180, 70 and 360. So the thing is, as the value of theta increases, the value of cos theta decreases. So when the value of theta will increase, the overall value of cos theta will decrease. Since the overall value of the right hand side will decrease, the value of the left hand side should also decrease. So as the value of theta increases, the value of cos theta decreases. So this leads to a decrease in the value of cos theta. So the r would decrease since r equals to w cos theta. So the answer to this question is A. Number 8. A cylinder of weight 1.5 newtons is placed on top of a vertical spring and the spring compresses by 3 centimeters as shown. What is the spring constant of the spring? So the thing is, the spring constant, we have the formula F equals to kx, where F is the force applied, x is the extension, and k is the spring constant. So we can easily make k the subject, F equals to k equals to F by x. So F is 1.5 and the value of x is 3 centimeters. The value of centi is 10 to the power minus 2. So the answer comes as 50 Newton per meter. So the answer to number 8 is D. Number 9. The path of a projectile is shown. So this is a projectile motion. The launch position is this and it goes in this direction and lands in a new direction here. So the one thing that we can notice is the vertical point at which it is launched, it reaches the ground at a later speed. So the thing is, if we launch something from this point, it goes to this point, it travels this distance extra when it is going down. So clearly the vertical velocity would be increased in this position. So the thing is, when we have an initial velocity, for example 50 meter per second, we have an initial velocity of 50 meter per second upwards. When it reaches this height, we would have minus 50 meter per second going downwards. But when the ball reaches this height, goes the extra mile or extra distance, it means that the final vertical velocity would be greater than 50 meter per second. Okay, so this is one. So the projectile landed at a height lower than the height from which it was launched. Assuming there is no air resistance. No air resistance means that the object is, for example, if it is going in this direction, the vertical velocity is dependent on the gravity, right? The vertical velocity is dependent, the vertical component of the velocity is dependent on the gravity, and the horizontal component is almost constant. The horizontal component of velocity is almost always constant. The horizontal velocity decreases when there is air resistance, right? So the thing is, when there are two scenarios, without air resistance it will go like this, but with air resistance it would go like this. It would travel less horizontal distance, so the vertical velocity would decrease when there is air resistance. So at maximum height, the horizontal velocity is minimum. It is not correct, since the horizontal velocity is almost constant always, since there are no air resistance. B, at maximum height the vertical velocity is maximum. This is not also correct, because at maximum height the vertical velocity is 0. At C, the initial velocity, horizontal velocity, is equal to the final horizontal velocity. This is correct because there are no air resistance acting. Part D, the initial velocity is equal to the final velocity. It is not also correct because it is traveling the extra distance when it is going downwards. If the ball reached the ground, the same level of ground as when it was launched up, in this case the option D would have been correct, but now the only correct option is C. Number 10. A constant resultant force acts on an object. Which of the following graphs is correct for the motion of the object? So the motion of the object, there is a constant resultant force. So always when there is a constant resultant force, or if we are talking about resultant forces, we always consider the formula F equals to ma, since it is physics unit 1. So when there is a constant resultant force, there would be a constant acceleration. So since there is a constant acceleration, one of these four graphs will represent constant acceleration, right? So what is acceleration? Acceleration is basically change in velocity by time. So the change in velocity by time should be constant for one graph, and change in velocity by time would be the gradient of a velocity time graph, and the gradient should be constant. So we need change in velocity and time. We have time here but no velocity. We have velocity here, we have velocity here, and time here. And in this graph, the gradient of the graph is constant, so there is constant acceleration, and so there is a constant resultant force. So the answer to this question is C. So if this free video helped you, consider liking and subscribing, since these videos need a lot of time and effort to make. So thank you for watching. Hope it helped you all.